Computers have came a long ways from the days of the IBM 5100, but is far from being complete. Today's computers run our everyday lives, from directing traffic to helping us navigate around the globe with our GPS. They have become an essential tool in our everyday lives and will continue to play their part in the future. Computers such as the supercomputer or the IBM Watson have been able to calculate mass amounts of data and have given us a platform which to test complex theorems and ideas such as the Big Bang and string theory, or Trump fields in the game of Jeopardy. These advancements have also paved way in other fields such as medicine and astrology, allowing doctors to analyze the brain in more depth than ever before, or allowing astrologists to study the black hole in the center of the galaxy. Computers have made a huge impact on our development over the last 3 decades. Think if we had 2 centuries of advancements in the computer, how far we'd be. Sooner or later, we will have probes that can detect wormholes in space, or robots that will be able to walk the dog. The applications for a computer are limitless. Game engines have evolved alongside the computer. We can now do things we used to only see in sci-fi films. As the game engine evolves, so will the physics that govern them. Might be a few years till we can immerse ourselves into a virtually simulated world, like the movie Gamer, but the reality is coming soon. With strong pushes from the military and science industries, we might be around to actually test these new simulated realities, built from supercomputers and game engines. Some of the most advanced gaming engines, such as the Crysis and Frostbite engines, have been huge hits, but are still far from being adequate when it comes to the physics. I feel that the faster computers and game engines evolve, the science and technology will for us. Where would it be if we weren't able to simulate the Big Bang on one of IBM's supercomputers? We'd still be at square one theorizing about when it happened. Currently, a group of scientists have extended their own supercomputers and used 2 of the fastest supercomputers to conduct research on black holes. Since scientists cannot replicate a black hole, they rely on computer algorithms to study the massive dark objects using the computer to simulate the mathematics and graphics of what they cannot see directly. Their lab, consisting of 85 nodes with 4 processors each, process data at a rate of 10 gigabytes per second. Besides the fact, game engines have been used to simulate theories such as gravity detector, Einstein's light theories, and others. More useful applications such as the flight simulator and military training apps are only in baby stages of development, but will put a heavy load on game engines in the future, furthering their development, which will then trickle down to the more mass audience.